Hey, seventh graders. Today you guys are going to be doing day 2, antimalarial drugs and drug resistance. Your learning targets for today. I can explain selection pressure. So you guys are going to learn this kind of new vocab word. It's really not something that's unfamiliar to you guys. We're just putting a name to it now. And describe how it influences the natural selection of malaria parasites and drug resistance. So like I said yesterday, you guys are really going to get into today what drug resistance is and how this involves natural selection. Okay, and I can model how a population may shift under specific selection pressure. So again, when we change an environment, you guys should already, again, have a pretty good background on how a distribution of traits in a population might shift. In this case, the traits we're looking at is malarial drug resistance. Okay, and then finally, I can model how mutations may cause drug resistance in malaria. So we have a little activity that we're going to do in class. You guys will have a little video to help you guys collect your data and graph your data. Okay, so moving on to your bell ringer, you guys have the message of the day. So go ahead, take a second, pause the video, and read that message. When you guys are done, you guys can come on back to this video. All right, so some vocab for you guys today. An antimalarial is a drug or a medicine that kills the parasites that cause malaria. So this is a treatment that we would use after someone has already been infected with malaria. Okay, and then resistance is the quality of preventing or fighting against something. So the more we expose things like parasites, bacteria, and virus to different antimalarials or antibiotics or antivirals, they actually can have mutations that cause them to be resistant. So you can give them the antibiotic, but they won't die. Okay, it's almost like they have a little shield that protects them. Okay, so for your guys' first activity, you guys are going to read Chapter 3, Antimalarial Drugs, a Selection Pressure. So you guys are going to learn a little bit about what selection pressure is. So when you guys pull up your assignment, make sure you guys are on Chapter 3. So again, antimalarial drugs, a selection pressure. You guys are going to learn a little bit about what selection pressure is, how that would be applied to rabbits in an example, and then how we would compare like the rabbit example to something like malaria. Okay, when you guys are reading, you guys are looking for the answers to these questions. You guys need to put these in your own words, not copy and paste it from the article. So what is selection pressure? What is considered selection pressure for malaria? What is an effect on malaria of this selection pressure? So what does that selection pressure cause happen, or what does it cause malaria to do, or how does it cause malaria to change? Okay, and then why does natural selection occur quicker in organisms like malaria than even rabbits or humans? Okay, so again, you guys will have that comparison between the rabbit population and the malaria. Okay, so go ahead, take a second, pause this video, read the article on Chapter 4, make sure you're in Chapter 3, or excuse me, read the article on Slide 4, make sure you're reading Chapter 3, and then answer the questions on 5 and 6, and then come back to this video. Okay? All right, so you guys just finished the article, and now you guys are going to have a little activity to do. Obviously, you guys at home watching this video won't be able to do the activity hands-on, but I did make a little video that models it, so you guys will use that data as well. So basically what we're looking at is if we were to apply a drug to someone with malaria, okay, that drug would kill some percentage of parasites in that person's infected body. Okay, so the first step that you guys are going to do is you're going to apply a drug. Okay, and you guys are going to see that depending on the amount of resistance that different parasites have, it's either going to kill a lot of them, a little bit of them, or none of them at all. Okay, so in your guys' population, you guys are going to see 3 different cubes. The green cube are representing all the parasites that have no resistance at all. Okay, if we apply a drug, we're going to kill most of them. Not 100% of them, but most of them. Okay, and then the blue cubes are going to represent those parasites with some resistance. And finally, the purple cubes are going to be high resistance, meaning you're going to apply a drug and you're not going to kill any of them because they have kind of a little shield built up to protect themselves from that drug. So the first step is to apply the drug, and you guys are going to see that certain individuals die. As we've learned several times throughout the natural selection unit, when we have a change in environment, those that are best suited for their environment are going to be the ones that live long enough to reproduce. So when we apply the drug, some of those parasites are going to die, but the ones who do not die are going to live to reproduce. So we're going to look and see anytime we have a reproduction, we have a potential in the division of those cells for mutating. And as we learn with parasites, they mutate a lot quicker because they have such a quicker lifespan and they reproduce a lot quicker. So your mutation card could have something anywhere from no mutation at all, because that really happens quite frequently, It could have a little bit of mutation where maybe one individual mutates, or it could have a lot of mutation where a couple individuals see mutations in their DNA. Okay, and then we're going to take those mutations and we're going to allow those individuals that are still alive to reproduce. And then at the end of that generation, we're going to draw a histogram. So we're going to go through 6 rounds of this. Okay, so here's your guys' starting population. You guys are going to see in the little video I show you here in a second that we're going to start out with 8 individuals that have no resistance to antimalarial drugs. We have 1 blue cube, which represents some resistance, and then we have no individuals right now at this time that have high resistance. Okay? Anytime we apply a drug, this is the pattern that you guys will use to kill off your individuals. Because the green cubes have no resistance, more of them are going to die. Notice that not 100% of them die. So we're going to kind of do this pattern: survive, die, die, die. So as we count through our blue cubes, we're going to go survive and keep that one, and then the other 3, die, die, die. They're going to die. Okay, with the individuals with some resistance, 3 are going to survive and 1's going to die. So we're going to do the pattern: survive, 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 die. Okay, and then finally, high resistance, notice that all of them survive. Okay, the next thing you're going to do is draw a mutation card. A mutation is a random change to a gene that sometimes results in a new trait. Notice how sometimes is kind of italicized there. Okay, it's not always going to be the case. You guys are going to actually see a couple cards that have no mutation whatsoever. Okay, and then once mutations are complete, you guys will reproduce. Parasites are a little bit different than humans. They don't need like a mom and a dad to reproduce. They actually do what we call asexual reproduction, where they just kind of make a copy of themselves. So like now we have 2 of me. Okay, so you can see this one makes a copy of itself. So here's the original guy, and then here's his copy. Original guy, copy. Original guy, copy. Okay, and then any mutations that we had would take change there. So it might be no mutation. It might be, you know, one of these green cubes has a random mutation, and then you guys are going to pull a random individual out of the mutation bag, and that's going to be the offspring. Okay, so again, you guys would then draw your histogram. If at the end of a round, this is your population, you guys would draw your histogram. Your green bar would represent no resistance, your blue some resistance, and your purple high resistance. So you guys can see here's the round 1 histogram, round 2. Okay, so here are your 6 rounds here. Okay, you guys actually already have your first histogram done for you on slide 8. So your 6 rounds after that are going to be graphed here. So you guys aren't going to have any of your original 8 greens and 1 blue graphed on here. That's going to be already on slide 8. Okay, so for you guys to collect data on this, watch this video right here. If I open that up, it's going to take me into YouTube. The video is about 9-10 minutes long, but it goes through all of those rounds pretty quickly. Okay, so make sure you watch that. And then complete your histograms and then answer these questions. In what ways do your histograms look similar? In what ways do your histograms look different? What happens to the number of parasites over time? What happens to the traits of resistance over time? And predict what you think would happen if we did 8 rounds of this activity instead of just 6. What about 100 rounds instead of 6? Okay, so take a second, pause this video, and you guys are going to complete slides 7 through 15. Okay, really all you guys are going to be completing on that is 13, 14, and 15. Your instructions are just on 7 through 12. Okay, so go ahead and pause and complete those. All right, so as you guys have learned from the article, selection pressure is something in the environment that affects an individual's chances of surviving. So if we look at the rabbits in that article, its selection pressure was the fact that the environment turned cold, and we've had a lot of examples of that in the natural selection unit. Okay, so some things you guys need to keep in mind is anti-malarial drugs act as selection pressure on a population of malaria parasites. So when an individual takes anti-malarial drugs, they're changing the environment inside of their body for those parasites. So that's the selection pressure, is having the presence of those anti-malarial drugs floating around the body. Every time a malaria parasite reproduces, a mutation that could lead to resistance to a drug has a chance to occur. It doesn't mean it always occurs, okay, but it definitely has a chance. And because those malaria parasites reproduce so often, we kind of increase the chances. Same with bacteria and viruses as well. Okay, we increase the chance of a mutation. And a mutation can result in a new trait that is adaptive or non-adaptive, or the mutation may have no noticeable effect, which happens more often than not. And then finally, parasites with the adaptive trait of drug resistance will be more likely to survive the exposure to that drug and be able to reproduce and pass this trait to their offspring. This shifts the distribution of traits in that population so that many more individual parasites have resistance for that drug. So again, our whole goal in this unit is going to be to try to lower this resistance and kill as many of these parasites as we can effectively. Okay, so moving on, I'm gonna have you guys take a second, pause this video, and you're gonna watch this video right here, natural selection in malaria. Looks a little something like this. When you guys are done, come on back to my video and we'll move on. Okay, last little spot for today. You guys are gonna read chapter 4. So when we go into our library, make sure you guys are on chapter 4, anti-malarial drug resistance, and you guys are gonna learn a little bit more about drug resistance. Pay really close attention to these graphs and read their captions and kind of try to figure out what you think they mean. Okay, the questions you guys are going to answer from this article using your own words, not copy and pasted from the article. What effects do malaria treatments have on drug resistance? How do malaria treatments influence drug resistance? And once you guys are done with that, you guys can go ahead and do your exit ticket. It's called Ducks in a Row. So what are the first and second most important things you learned today? So get your ducks in a row. What do you think is the first and most important thing you learned about today's assignment? And what is the second most important thing? Okay, this should be about the actual content of the assignment, not just like, I learned that if you hit delete, your whole slide deletes. So make sure you guys do something that's pertinent to the information you guys are supposed to learn in this article. That being said, I hope you guys have a great day, and I will talk to you soon. Bye.